Good morning. Welcome to another Random Code stream. This one is the first part of I don't know how many. This is completely new territory for me, and it was an idea that came up in my head about a month or so ago, and I've been spending time just researching things on the side, looking up stuff, and seeing if at least I think it would be possible. I think it's possible. I think it's definitely possible. But, you know, it could all just crash and burn too. So this may not end up being a great idea. But I haven't done anything with this library in quite a long time. Yeah, I've been teasing it for a while. And, you know, I think at this point, I'm like, okay, I'm at least confident enough that I can do enough that if I fall on my face, oh well, who cares? You got to take that. The only way to get to the end or fall off a cliff is you got to take a step. And if not, you're never going to get anywhere. So I figured, let's give this a whirl. Let's give this a try and see how far things go. I'm going to get my music going here. And really this first stream is probably going to be a lot of talk and discussion about what this actually does and what I want to do. Although I do I'm hoping to at least get some project and code structure in place. And then I have off this week, even though I'm leaving for San Diego for a conference, VS Live, that I'm going to be speaking at. So I won't be home the rest of the week, but at least I can have a start. And that might get me thinking about some things that I could look at while I'm at the hotel. Because I'm actually going to be on vacation. I'm not going to be working. I'm literally taking the week off, so that'll be nice. So, what is all this? Coffee, so good in the morning. Okay, so first of all, I want to explain, and I've got some notes here that I'm going to be going back to talk about what this is. So, what is this thing? This library is something called EmitDebugging, and I only have 3 commits on it. The first one, which was in 2014, that's 11 years ago. And I think the reason I committed everything here is because it used to be on this site called Codeplex, which I don't even think the site even exists anymore. Like, you can't even go to the URL. I'm not sure. I'm not even going to give it a try. But that was Microsoft's first foray into, hey, you can use Codeplex to host all your projects, you know. And then over time, long story short, it became obvious that Git and GitHub was the clear winner. So they eventually moved all their stuff too into GitHub, and then eventually sunsetted the site. So this hasn't had a lot of updates. I mostly put it out here because I thought it was an interesting project, but I really didn't do anything else with it. And at one point I actually had made it archived, and because I wasn't going to do any more work on it. So what it is a way to say, hey, if you're using System Reflection Emit, which is an API in .NET that lets you emit an assembly using IL, and that's not easy. That's actually really hard to do. In fact, hold on. I should have got this, but hold on, let me get this. I was grabbing a book off my shelf, and this lovely picture of my wife and I were right in front of it. So that was from a party from a company that I worked at years ago. So this is, I called it SIL programming, under the hood of .NET. And this is literally, I wrote this because I wanted to learn about the underpinnings of, you know, both C# and Visual Basic and other languages. Because one of the things when .NET first came out was this notion of multiple languages, one runtime. For Java before, it was one language to rule them all. Now, as history has shown, it's C#, at least for .NET, you know what I mean? the number of languages that were there originally were a lot. There were a lot of experimental languages like Oberon, Component Pascal. I think Eiffel had an experimental implementation. So yeah, there was other languages that were targeting it, but it became clear after a while that C# and VB and F#, and for the most part C# is the language for .NET. So anyway, I at least wanted to learn about what this intermediate language was. And so I spent a lot of time, wrote a book on it, and one of the projects that I actually did for the book, let me go to that site, Dynamic Proxies. And so this is also one that's archived. This one I'm not bringing back. And the reason I'm not bringing this one back is because there's already a library called Castle Dynamic Proxies out there that pretty much, if you want to do that, that's the one that has had the most. In fact, we can look that up. Castle.tle Dynamic Proxy. Okay. So this one includes this one. So I think this is the right spot for a Castle project because there's a couple of other things there. But yeah, this is still getting, like, the guy commit 6 months ago. This is the one that if you want to build a proxy for a type, which is essentially what my other project does, the one I spend a lot of time on, Rocks, it's creating a type that inherits from a type and then intercepts all virtual calls, more or less. But that's done using source generators. This was done using IL generation. So it is kind of the one that's like, if you want to see an example, this is the standard. I do take pride that mine was the first. Again, this is something I built it when I first created my book. And then eventually I put it in Coplex. I moved it here, and I kind of lost some patience in building it. So yeah, I really didn't. I said enough is enough. We're gonna archive it. So if you, and there's also something called Dispatch Proxy that you can use in .NET. Point is, I built this. It did work. It does work technically, although it's targeting .NET Framework only. I think. I don't think I ever updated it for .NET proper. But why does it think there's small talk? That's hilarious. That thinks that my repo has small talk in it. I have no idea why. So anyway, one of the things I discovered when you were doing things with IL generation is it's very, very easy to screw things up. Like, insanely easy to do that. And you can get some really bad exceptions, like invalid program exceptions, execution engine exception, just stuff that you normally don't see in .NET applications. That's because you did something low-level, some low-level wrongness. Yeah. And so out of that frustration, I built this EmitDebugging project. And so what this is intending to do, or what it does, is that it generates a source file for emitted code with breakpoints built in. So I'll show you an example in just a moment. I'm 100% agree with just trying ideas out. Always learn the most when I go down a rabbit hole. Even if it goes nowhere, most of the time you come out with something I better understand. Yeah, exactly. And part of the reason I want to do this is because I want to have an example using interceptors. Like I like in fact, I'm going to be doing a talk up in Winnipeg in like the third week of September. And that's on like building packages and tools using Roslyn, essentially. So I want to have examples to show analyzers, code fixes, refactoring, source generators, building tools like console apps, tools. I'd like to have an interceptor example as well. This one's going to be a little bit off the beaten path, but I do want to at least have something there to show. So this is also a vehicle for demonstration purposes. So, but yeah, a lot of this is just learning and seeing how to get things to happen. So how does this library just work? Because you can still reference it off of NuGet. So to show this, I built this little example up. And so this is typically what you do with System Reflection Emit. And to be clear, there are other libraries that if you're going to do IL generation, or if you're going to do what's called PE reading and writing, PE stands for Portable Executable. There's System Reflection Metadata. That's another library you can use. There's Mono CSL. There's another one that I just heard about. I've got my notes on this. It's zoom in a little bit. ASM Resolver is another one. So there are some libraries that you can use to do this. This is just the one that's in .NET proper. It's been there since .NET 1.0. Will you play Silksong? Someday, yes, I will. Not in this stream. This is about coding. I do have Silksong. I did buy it, but I'm not playing it right now. I just because, and everybody's playing it, and I didn't want to get caught up in the not first mentality that some people have with playing a game as soon as it comes out. It's one of those, I liked Hollow Knight. I really did. I thought it was a really fun game to play. And I'm looking forward to spending oodles of hours in Silksong. There's other things I want to do right now. So it will be coming up at some point in the near future, just not right now. So anyway, so this is how you create an assembly, at least the part of it. So you have an assembly name, and then you say, and notice that this old demo is targeting, is it? Yeah, my default for all this is 4.8. At least that's the way it's been, and we'll come back to that in a little bit. But this is how you do it in .NET Framework 4.8. So you go to the app domain, which doesn't exist in .NET anymore, and you say define dynamic assembly. You can add this debugging attribute. That just adds a attribute to say this is a debuggable assembly. You don't have to do that, but that's an indicator to say that this is a debug assembly as well. You create a module. Modules have been around since 1.0. They will always be there in .NET, but nobody does anything with them. They're just a legacy holdover that's way too hard to pull out. So the intent of modules, I think, was assembly could have multi-modules, so you could have you could have types in multiple modules. But it was never really fully clear as to what that actually did in .NET. Well, I mean, it was clear to the designers and implementers, but the general crowd really didn't get the understanding of it. And in retrospect, I think it was overtly designed. It really didn't provide a lot of value. But you still technically have to have your types in a module, okay? And your module is in an assembly. So every assembly these days has this in there. You don't see it, you don't care about it, and you only have one module per assembly. So yeah, that's just a holdover. So you define your module, then you say I want to create a type, and you can start seeing some things in here like I want it to be a class, I want it to be sealed, I want it to be public, and it derives from object, which everything does. And then you get to this defined document. This is a symbol writer. So this allows you to basically write debug symbols into your assembly. Okay. So all of this is good. And at this point, you could say in a type, in fact, I'm going to switch over to another example here, because this example is using .NET proper. So to create a assembly, well, one way you can do it is to say, I want to create a persistent assembly builder. There's also, I think you can just say var x is equal to new assembly builder. No, you can't. I forget. That you can look up the code to see how you actually do it, but I use this persistent assembly builder, so yay. But kind of the same code here, but then you'll notice if I want to build a constructor on the type, I say define constructor, and you have to start getting into some things you might have seen before, like what's RT special name and what's hide by sig. So, stuff like that. And then you get into the IL generation, okay? And so this is where you really have to start understanding how method invocation and definition really works underneath the scenes. If you have an instance method, for example, the 0th argument that's pushed onto the stack is is the object instance itself. And that's used to figure out which object you actually want to call an instance method on. If you do a static one, you don't have to do that. So if I want to call the base constructor, I have to load the first argument, or the 0th argument. That's the object I'm creating. You'll see also that I'm doing these marked sequence points. And the reason I'm doing these is because I have this file that I've created, and that was actually created because of my demo, which I will get to in a moment, that kind of creates a pseudo IL document. Okay. And what I'm trying to do is put in sequence points that relate to this. Or I think it might be this, I'm not sure. But somewhere to say, hey, as you do each opcode emission, mark that sequence point. Okay, and then I can get the constructor for the base type. I can call it, and I want to mark that as a sequence point. That would be this, and so on. Okay, you can define methods as well. And this method it'd be a public instance method that returns a GUID and takes no arguments. And the same thing here. We're basically going to create an IL generator where we're going to say call the new GUID method on GUID. And then we return. So this method would return a GUID. Now we'll come back to this in a moment, but this is showing you the actual system reflection emit code that you would use to emit a method. And you can do I think you can do define field define, if I say type builder here, define, wait, not type builder, I'm sorry. Yeah, I want type builder. Wait, what's type builder? There we go. Define constructor, define event, field, method, property, type initializer. So there's other things you can define on the type as you would expect. Yeah. The problem with this is that if I was building my dynamic proxies library, I would want to be able to debug into it. This is what I love about source generators, is because it's all in C# and you can easily just debug right into it. It's so much easier. And that's really why I've had an aversion to ever going back to my dynamic proxies library, because I'd much rather build something like that in a source generator rather than doing that in IL. If you're generating IL, you pretty much are doing a compiler. You know, there's really no point, especially with source generators, to try to do that with IL, in my opinion. You're much better off using a source generator. But if you're here and you do something wrong, it can be really hard to figure it out. So I was like, well, I found out that you can do define document, you can mark a sequence point, you can do these things. And I was like, couldn't I do that? Make that somewhat transparent to the user, rather than me having to remember, well, where are the locations in the document and how, what IL am I actually generating? Because those strings in that code is all being, you got to generate that somehow. That's not done by system reflection emit for you. Okay, so coming back to this example, this is where EmitDebugger comes in. So I added these wrappers like assembly debugging. This wraps an assembly builder and also takes a symbol writer. And then we get type debugging, which that wraps a type builder, and that allows you to create a method where you could debug the method, and where you still define the constructor, but you pass it into method debugging, and then you get a constructor method debugging method. Now you'll notice here that we're using the emits, but there's no symbol there's no document that we're aware of. We don't do mark sequence point. Same thing here. We just emit. So the intent is that you just emit the things that you normally would. These debugging types that my library created, wrap these so that it intercepts the calls for you. It would make the emit calls underneath the scenes, but then it also does a whole bunch of code generation and sequence point marking for you. Yeah. So great. This all works. And in fact, once I get down to you have to call create type, you have to do this because that will actually literally create the type, and now it's available for you to use. You can save it if you want, but you don't have to. But now what I'm going to do is I'm going to create an instance of that type. I'm going to get that method so I can invoke a method that gets me a new GUID. The magic kicks in at this point. If I run this, which makes sure, yep, that's the one that's going to be run, and I F11 into this, it goes into the generated IL and the breakpoint here. Okay, and you can see down below that locals will also have if I had variables here, which I don't, but if I had parameters, if I had variables, they would show up now down here in the locals window, which is really nice. You just don't see it because in this case it's a very simple call, and we're going to return the value out, and that's what we get. Yeah. So this, to me, when I was just doing IL generation, this was a godsend because this allowed me to have some indication as to, well, what went wrong? How do I debug this? What did I miss? Is a sequence point just like a line of code? Not really. A sequence point is saying, essentially, if I go back up to this example, and I hover over mark sequence point, this is basically saying, for lack of a better way to describe it, I want in some document here, a symbol document writer, if you look at the parameters, you have a start line, an end line, start column, end column. So it's saying at this point, this is a breakpoint. Okay. And which is great. So what my EmitDebugger is doing underneath the scenes, when you emit an opcode, it's actually, if I can F12 into this, it's going to actually create some text for that opcode and also create a label prefix. Okay, so then that's what you see here. That's what it's generating, something like that. And then it will emit that opcode, but it will know, okay, well, we just added this text of this size, blah, blah, blah. And so what I'm trying to remember how this actually all works because it's been a while. Oh, I'm sorry. I think if that's right. That's right. If I go into write text here, is that what does it? Yes. Okay. Yeah. This is a type that I created. It's a code document. And what it will do is it will generate the string code for that IL stuff. And then it knows, okay, for that line, it's of a certain size, so then it will call mark sequence point for you. Yeah. Now you'll notice that actually happens before we actually, on the underlying IL generator, that it does the mark sequence point first, then it does this. You can also do it in reverse. It's just saying this is a breakpoint. So if I step into it and I could actually have put a breakpoint here, and as soon as like the code execution would get to that sequence point, then it would stop there. So that's what they are. They're adding a breakpoint or sequence locations that you can put a breakpoint in your code, and then the debugger honors that. So you could make it multi-line, you could make it go across multiple lines, you can do whatever you want, but then that sequence point is a debug breakpoint that you could actually put in your code. So now that you know this, you can start to think about when you're putting breakpoints in C# on a line, or if you put it within like link statements or whatever, that the underlying compiler has to allow you to put those breakpoints at those locations to make that all work. So, and I do not claim to be an expert on all this stuff. There's a ton of lower level stuff that goes on with debugging and setting up all the metadata and all this stuff. This was meant to be kind of a higher level extraction to make it somewhat easier for you to use. So again, the whole point of this library was to make it, the attempt was to make it easier to create assemblies where debugging was needed. Okay. And it worked. However, there was a big problem with this, is that I had to create all these wrapping types. These types that would wrap the underlying types that are in that are in System Reflection Emit, and create basically like one-to-one binary mapped methods, so that if you already wrote code to do this, it wouldn't be so hard to move over to these types to now introduce them into your code base if you wanted to. But I didn't like this. I really did not like this, because it changed your code too much, in the sense of, well, now I am using this API. I'm really not using the Reflection Emit API directly. It would have been much nicer if I could have inherited from types like this type builder, or this, let's go back to this example, the IL generator, and then intercept those calls. But none of these are virtual. None of these are inheritable. Like if you go to type builder or method builder here, and we look at its type, well, it is an abstract class. But if I go to type builder and I go to assembly builder here, this is a persistent assembly builder. This is sealed. So we have no chance. If you go all the way to the top, there's no way that you can now hook define dynamic modules. So even if some of these are inheritable from, the root of all the creation is sealed. So it doesn't matter. You can't then handle all this yourself, if that makes sense. So that kind of sucks. But what I thought of at the time was, well, that would have been nice, because then you could just write all your code like this, pretty much normal, except maybe at the top you have one thing that you use, like a debug assembly builder. And then from that point on, everything still works. You have one line of code that you have to change. Everything now works, and it's very unobtrusive. Okay, but that just was not possible. So, this was a very this had very small usage, and it was cool to show off, but in reality, it wasn't very helpful. So that's why I eventually just archived it. Well, then recently, I was just thinking of, well, I want to have an interceptor example, and I didn't want to pigeonhole or fix it into something like square peg round hole type of thing. The circle goes in the circle hole. I didn't want to try to make something happen just to show off an example, and I didn't want to do just here's a logging example, because that's interesting, but that's also kind of sort of boringish, if that makes sense. So didn't want to do that. And I don't know why, but I started, somehow this came back into my head, and I started thinking, couldn't I intercept these methods? Would that be possible? Could I intercept these methods? And again, you don't have to do sequence point. You don't have to do define document. When you call like define dynamic module, we intercept that and do a define document for you. And then when you define type and define constructor and IL generator, we'll probably intercept those just to do some tracking of things. But when you call emit, we'll do that underlying code document or whatever thing and mark sequence point for you and call emit for you. And that way you just reference a library. None of your code changes. None, other than you're now referencing a library. And maybe we could put something in to say, well, if you could switch it on or off using some, build setting in your project file. So we either regenerate code or we don't. But if you have it on, or you're just referencing it for the first demo, it would do all these things underneath the scenes for you. And so that's kind of the idea, is ignore the sequence point code here, but just it uses all the system reflection emit stuff, and it transparently uses interceptors to generate code that will intercept stuff and let us actually then track things and do the debugging things that we need. What do we have here? A really weird attempt at doing something in .NET using something called interceptors. So that's the long and short of it. So now, again, I said this is why the first part of this is a lot of talking, because I got to explain it. I got to explain a couple of things here. You may have noticed that in the example that shows EmitDebugging, we have using statements. And this is actually kind of important, because to generate the IL, we need to kind of know when you're done with a type and when you're done with the method to close it off. The types in System Reflection Emit do SRE. I'll just abbreviate it to that. They don't implement disposable. So, and even if they did, you can't intercept a method that you don't see in code. You can only intercept invocations that actually physically show up in a C# file. So that can't happen. This has to be hard work. Well, I've been doing software development for 30 years, so this what I want to attempt isn't going to necessarily be easy, but it's also something that it's just a practice and a thing that I've done for pretty much my whole life. So I know a thing or two about this stuff. I'm not saying I never will say I'm like a 10x developer or an expert on anything, because I can't do that. I just do my best, learn my best, and see what I can come up with. So anyway, so that helped, because when you follow the using, I could say, like with a method, you're done defining the method, so we can instead of outdenting, we can indent, put the curly brace there, and we know you're done. With SRE proper, that doesn't exist. So we're going to have to be a little bit tricky, or at least assume that the user is doing things in a certain way. Like if you define a constructor here, okay, fine, this is all defining constructor. But soon on that type builder, if you do another define method, define field, define whatever, that means you're done with the previous definition. And then we can close it off and say we're going to move to that. If you create type, then whatever the last thing was that you were working on, we close that off, and then we create the type. I mean, we have to have some spot to say, when are you done with the previous definition in your SRE code? No, it's perfect. Some people are better in one thing than another, better than others. Yeah, I mean, that's true. I just, I've always said I do what I do. And to some people, it might be like, holy crap, I don't know how you pull that off. To other people, because based on their skill level or what they've studied or what they've looked at, they may go, oh yeah, I get it. No big deal. I've always done software development because at the end of the day, it's fun. It's, I mentioned this before, I think on previous streams. I started doing software development when I was in 7th grade with an Apple IIe, I think it was, but it was basically an Apple II something or other. And you can look those up, and it's basically this kind of like white colored computer that had, it was all in one unit, you had the keyboard and whatever was inside with the processor, and then you had the side thing to put the floppy disk in. Floppy disks that actually flop. That's how old I am. And I was learning how to code in BASIC and write programs that let you like do my math. I was in pre-algebra at the time, and I could actually write programs that was letting me figure out how to do my math problems, and writing simple programs that were like, you've entered a dungeon, you've entered a room, you can go north or west, which way you want to go. And so you had to start remembering the structure, and you enter a room. There's a goblin, what do you do? And you had hit points and random number generators. So I fell in love with it. I actually did. I was like, it was really cool, even though it took me a long time to truly realize, like, I knew computers were definitely going to be a thing. That for some reason I picked that up right away. This is going to be a thing. But it was like, to me, as a thing that I would use, not necessarily program. It took me till my master's thesis and when I got into grad school to truly realize, yeah, I like computer programming. So anyway, so we're going to have to be a little clever when we generate the code to intercept these things, to say, like, if you create define method, has there been another definition created? And if so, then close that off. And then do this. If you say create type, close off the thing that was made and do that. Again, this is kind of for demo purposes. In the first round, it's kind of a proof of concept. We're going to be very simple in what we do, and then we can build off of that later. And it's just to get the mechanism in place and see if we can do it. Now, another thing too that I want to bring up is this example is using .NET Framework, which I don't use. I've been targeting just .NET, and there is a difference. .NET is the open source cross-platform version of .NET, and we're at version 9 right now. Version 10 is coming out in November. That's what I build everything for these days. .NET Framework is the old and busted. It's the closed source, even though I think technically now they've open sourced what .NET Framework does underneath the scenes, but that doesn't matter. It's Windows only, and there's no new work being done on it. It's 4.8 is essentially the final version of it. So it's kind of like you need to move to, you really should be moving to .NET at some point. And if you don't, you're just going to be stuck and making it harder and harder to stay on the latest and greatest stuff. So anyway, the thing about .NET Framework is that to create symbols is really simple. You said to define dynamic module, and if you notice, the third parameter is emit symbol info. You just say true. So now I have a module that's going to create debug information. And when I did all the stuff that I've been hiding, which is the mark sequence point things, it just all works. The debug symbols work. Everything works. You saw that I stepped into this method and I stepped into the IL that was generated, and yay, everything works. In .NET, it's not as easy of a story. A lot of the APIs look the same, but you'll notice define document. There is no third parameter. Or I should say, if I look at define dynamic module, there is no parameter, say, emit symbol info. Define document's also different. Down here, you'll notice that in fact, I should technically move this up here because that can happen before. You can do it whenever you want, but you know, it should follow that it's from the module. So there's no text, there's no Microsoft vendor or anything. You just look at what document takes. It's two properties, two arguments. Okay. Now you notice there's a whole bunch of P builder, blob builder, load context, crap code down here. This is me taking what's from the documentation to say, if I want to try to build a debuggable assembly, supposedly this is what you're supposed to use. I couldn't get it to work. I'm not saying you can't get it to work. I just couldn't get it to work. And that would suck from a demo perspective. How would I actually show this and make it actually work? But what I realized is what I really care about intercepting, what the methods that I actually care about intercepting are define module. Because when you define module, I'm going to create a document underneath the scenes for you, and I'll track that somewhere. When you call define type, I will also need to track that. Constructor, method, and so on. So, you know, I'll be tracking all these things, but I don't care what kind of assembly builder you used. If you need to create the P builder stuff, I don't technically need to do that. That would be on you for now. Maybe I hide that as well in the future. But what I can do from a testing standpoint is have all my tests target .NET Framework 4.8, and then I would say I want to create a dynamic module here, and I just turn on create symbols, and then everything underneath the scenes would just work. Okay. And again, this is a proof of concept. The first thing is just to get something to work. What I'm really concerned about is the code generation and the interception. We're using these things called interceptors. That's what I need to do. So what's an interceptor? An interceptor allows you to say, hey, you're invoking something. This is a method. Doesn't matter what it is, just you're doing a constructor. You're invoking this method, blah, blah, blah. Okay. Well, in C#, they added this thing called interceptors. So interceptors allow you to say, when this method is being called in your code, I want you to actually call this method. And then you can do whatever you want in it. So it won't actually call this. It will call your intercepted method. And if it's an instance method, it will pass in the instance. That will be the 0th parameter, because you need to know which instance you might want to call something on based on what you're doing in your interceptor. Okay. So to do this, you need to build a source generator, because a source generator will examine your code as you're typing it. You can find method invocations, and then from those method invocations, you can generate code that puts all the intercept functionality within it. Now, what does that look like? Again, if you don't know this stuff, this is a lot that I'm throwing at you, but it is somewhat important to know. So there is a really good article. This is written by Andrew Locke, I think his name is. And I can put this. Can I put it in the chat? Sure I can. There you go. So if you're really interested in looking at this, you can take a look at this article. He talks a lot about how this works. I'll also put in this document. This is from the .NET team proper that talks about how this works. So basically what you do is you create a source generator. That I know how to do. And in your generation, what you'll do is put in this attribute. So doesn't matter what version of .NET you're targeting. And you also put it at the file level, because then you can put it just within your file. And this will all work. This all actually works, which is kind of cool. And then what you can do is you know, within your source generator, you do syntax provider. Sorry, you're looking for methods to intercept. And once you do that, then you can take that invocation expression, okay, and do whatever you need to do to generate it. And you notice this interceptable location. I think the document here talks about this. Get interceptable location, because the second parameter to the attribute, it used to be like file and column name and all this other stuff or whatever. They've now turned it into this opaque structure. And I think it's kind of forcing people to be like, if you really want to create an interceptor, you have to do this in a source generator. So the source generator has an API now that allows you to say, hey, for that invocation, get me the interceptable location. And I can say, now, what he's doing is, this is a candidate invocation. This is something I might care about. Okay. And okay, great. That's wonderful. So once I have all that, then you can actually start going in and creating, like in a string, the code that you want to generate, the intercepts location attribute. And then what he's doing here, this is his interceptor that's going to now, it's hard to read because this is like code, mashing code together. But his interceptor in terms of what he'll actually do. So that's what I'm going to try to attempt. I'm not going to get done with this today. There's no way. I don't have the time with it. But what I want to do in the remaining time is just get some stuff set up. Maybe get to the point where I can write a test to see, am I actually generating what I think I'm supposed to be generating? We'll see. Okay. So that's probably a massive whirlwind, especially if you have never gone into anything Roslyn based. You've never looked at source generators. You've never looked at interceptors. You don't know what IL is. You don't know what system reflection emit is. A lot of this is probably just like whoosh over your head. And I totally get that. But this is something I'm having fun with, and I want to see how far I can get with it. So we're just going to start today. Now I have all this in a branch for EmitDebugging, which I've now unarchived. if you ever look at my repositories, I unarchived it because I want to start doing work on it again. So we're going to see how far we can go with this. So the first thing, and I renamed all of the current, if you see up here at the top, I renamed all the current projects to old because I want to do the new hotness. So we're gonna start doing that. Okay. All right. So I want to say add new project. Yeah, it'll be a class library. We're going to call it EmitDebugging.analysis. This is something I've learned that you want to keep your source generators, your analyzers in one project. And then if you ever write code fixes or refactorings, those go in another project. You keep those separated out. And so I've fallen on the pattern of I put all that stuff into a project called analysis. So it's just a naming convention I came up with. And we'll say, sure, standard 2.0, because it has to be standard 2.0. Actually, what I also want to do is we'll bring up another project that I'll use as a template, auto deconstruct. And so I can kind of copy and pasta from this one the way I want things set up. Now in this example, my build props file targets 9 as a default, but you can override that in a project. And so that's what we want to do here. We're basically going to take most of this, not all of it. But let's get rid of that, open this up, do this, do that. And we'll grab that. Say embedded, sure. We're not referencing a project, but we do want to have references to these things. And to have references to those things, we need to come back here and grab from our packages. We need analyzers, so we need that one. And we'll put that in our packages props. Okay, and then we also need C# and net analyzers. So, and we're also going to take some testing ones as well. Actually, we might as well take all these if I don't have them in here already. XUnit is because that's the test that I have for the current project. That's if I actually make this all work, whoosh, they're going to go away. I'm not going to have, because I do not like XUnit. I like NUnit. It's just a preference. So XUnit, yeah, it's legacy. You know me, Mitch. I'm not a fan, but it was there, and I'm not going to change any of the existing stuff. If this all works and I publish a new NuGet package, eventually I'll get to the point where all the tests are in NUnit, so it will just wash out. But I got to have it here for now because I can't have the existing code, which I might want to take a look at, to fail compilation, so I still got to have it referenced. I know, but, you know, one does what one needs to do. Yeah, we need that one as well. Okay, so now we have that in place. We should have everything referenced that we need to have referenced here. Okay, so now what do we want to call the class? This is the generator. So in this project, for example, if I looked at analysis, I have an auto deconstruct generator. Do I just call it EmitDebugging generator? Why not? Naming is hard. Anything that I've learned about, excuse me, anything I learned about code is that naming is hard. Actually, we can just do this. Generator. All right. And we like file scope namespaces. And we'll use this again as a template. So we're going to say it's going to have generator on it. It's going to be sealed. And we are going to implement, nope, not that. We want incremental generator. Okay. I was shocked. Yeah. I've said that in other streams that my go-to framework is NUnit. Though I might be tempted, I don't know. I don't want to be tempted on doing too many new things on this project. But I've said I'd like to look at T-Unit. And T-Unit is a new modern testing framework in .NET that uses things like source generators and all this fancy stuff. And I've been saying, I got to find a project to use T-Unit on, but I don't really know if I want to also throw that into the mix here as well. So let's leave that off the burner for now. Okay. So we'll implement this interface. Okay. No. We want too much things to tab over and stuff. Now, here's one thing I have to be really clear on. For most source generator projects, if you ever create a source generator in .NET, you should, by default and almost always, unless you have a really, really good reason, which I do for Interceptors, you should be using something called forAttribute with metadata name. And what this is saying is I'm looking for places in my code that are marked with this attribute of this name. Okay. The reason why is because this is highly optimized for Roslyn to find. And that's what the .NET team will tell you. It's much faster for them to find a where attribute, not the definition of an attribute, but the usage of an attribute in your code. It's much faster for them to find that than it is to find other things in your code. And it's not to say their compiler is slow. It's just, this is just the way it is. This is typically faster-ish. So if you want to do anything with source generators, you should think about, well, what I need to do is put an attribute somewhere, and then I can use that as a starting point to say, if that attribute exists defined in code, somewhere like on a method, on an assembly, then this would get invoked, and then I can do source generator stuff by looking at that and figuring out what I need to do. The original way with how are you, man? I can take that in many different ways. The original starting way was to use something called a source generator interface. And you can still see that here. Don't ever use that. That's actually, like, they eventually want to just make that deprecated and obsolete. So, because it's not the optimal way of doing things. But you can still kind of do what the source generator did, because if you look at context and I use syntax provider, there should be create syntax provider. What this allows you to do is do source generation based on the existence of syntax nodes within your code. But this isn't the ideal optimized way of doing it. If you could put an attribute on a invocation, that would be ideal, but that would also be invasive into your code from an interception standpoint, because now you'd have to say, I want to, at this point, all these invocations, I want them to be interceptable. So it actually doesn't work really well for interception. Yeah, everything's going good. I'm having fun with this. So, so you have to, if you're writing a interceptor, you have to use create syntax provider, and you want to target, that's why I have this article up here. You want to target an invocation expression. Okay. Now, let's just get this. So let's get some things in place. The first thing is a predicate. So what is the predicate? That's saying I want to take a look at a syntax node, and I want to return whether that's a syntax node that I care about. Okay. So the first thing I'm going to pass in here is a node and a cancellation token. Okay. And what I want to do is say is method is invocation expression syntax. Okay, so that's our predicate. Now we can do other things, like what this article shows is you can do you can look for is the expression a access expression where the identifier is to string, because that can narrow it down even more. The more you can narrow it down, the better off you are. For now, all I care about is is it an invocation expression syntax? Because we need to look at it. Is it on different types? Is it on this? Is it on that? You know, so this will narrow down enough to get to where we can do reasonably good decisions from this point on. There was a quote I read somewhere that is literally 100% faster, 100 times faster. Yeah, the for attribute with metadata name is definitely much faster, and they said they've done the performance analysis on it to show it is definitely faster. But again, for something like interceptors, you can't put attributes on invocations, so that's out just because that's not even a thing in C# and .NET. You can't do that. Even if you could, like I said, that would be very obtrusive in the code to do those types of things. So, you know, if you just want to intercept methods, this arguably is the right API. It's just, you know, it doesn't mean that your code, and if you're using this, like the generated code is the generated code. Once it gets compiled and you run your code, the interceptor's gone from that point. It's the code that it generated. That's there, but the interceptor logic that I'm writing here, that's no longer a part of what is running when your code runs. That's just the generated code that runs. So this is all like at compile time or IDE time. Okay, so did we find an invocation expression syntax? Now we want to write a transform, and the transform is going to take a context and a cancellation token, and we're going to do something with it. Okay. And this is barking because it's going to say use expression. That's my general thing, is I have to have expression body for members. Okay. But this is now where you can do a transform on what you have to say take what's in the context here and say var invocation node is equal to context dot node, and we can safely cast it here to this because we know that's what it is. So I don't really know what I'm going to be returning from there. We'll just save var locations for a name. Okay. Type arguments. Oh, because I'm not returning anything here yet. So, okay, fine. But at least it shut it up for a second. So we're good that way. Okay. So now we have an invocation expression syntax node. Great. What do we do with it from that point? Well, we're going to want to do something with, like what this article is suggesting is to use, well, the semantic model. Now you can get like the symbol from a syntax node, which would actually be easier. You can also use operations, and you can get an invocation operation. And that might actually be even easier-ish because you can look and say, what is the target method? What is its containing types? And so I agree with this. Let's do this. Okay. So we're going to say var invocation, shut up code. Var invocation operation is equal to context semantic model get operation on the invocation node. And we can pass in the cancellation token because you should do that. Okay. So now we can start making some choices. And this is where it's like we can say if invocation operation, we might want to bring up some of our old code here to at least look at this demo here. We don't care about this. We would care about dynamic module. But you'll notice again, like I mentioned, calling the dynamic module means that you have to be conscious about which one you're calling, because in .NET Framework there's 3 parameters. In .NET proper there's 1. So a little bit different story here. And in fact, in .NET Framework, there's one that takes 3. There's one that takes 2. There's one that takes 2, and there's one that takes 1. So, though we don't really care, you know, we can just say if you take the 1, then it doesn't matter if you're .NET Framework or .NET. They're both named. The other ones, you might want to handle a little bit different in terms of like the other parameters that are coming in. So anyway, we have to start making a choice as to which ones we actually want to care about here. And how we want to handle the interception. So if invocation operation dot declare, wait, what did he do in this thing? Oh yeah, target. Wait, what? Oh, okay. So this should be an I invocation operation. You don't like that. There, shut up. Okay, target method. And that is method symbol containing, or is it defining? No, it's containing. Containing type. Symbol equality. Compare equals. Default equals. There we go. So what we want to compare this to is context, semantic model, get type, meta, compilation, sorry. Meta, get type by metadata name. And I think what we could pass in here is system.reflection.emit. Is the method being called on well, persistent assembly, all these derive from assembly builder. So hopefully that's good enough. So if these two equal, that means you've called something on an assembly builder. So that's at least the first thing we want to look at. Okay. So if that equals, we can do something. Okay. Now we can kind of repeat this. We can say else if we don't care about, yeah, because we care about the assembly builder calling this on that. We don't care about this. Now we care about, did you call define type on a module builder? So we want to say module builder. Okay. And I could do something here where maybe I find the full name based on, but I really don't want to do that. Let's just put in the names of this to say, this is the thing I'm looking for. Does it match by that? So now we have an assembly builder. We have a module builder. We want to have else if type builder. And I'm going to throw in two more. There's going to be plenty more than this, but there's going to be, if I have a type builder, module builder could make a type. Type could make a constructor. If I have, for example, a constructor builder, okay, I could also have a method builder, and there'll be, again, field builders, event builders, blah, blah, blah. We'll get to all those, but we want to have a method. But we just want to start with, like I said, again, a simple path to see if we can get things working the way I want them to work. And I'm getting near the end of my time because, like I said, I knew there's no way I'm going to get this done. This is going to take many parts to finish, but it's the journey. We could say here with the system reflection emit assembly builder, we're going to have to kind of get the hard one out of the way, which is, you created an assembly. I don't care how you created it, but you created an assembly. Okay. So once you call the dynamic module, we want to basically create a document underneath the scene. So we need to see now if invocation operation name is equal to define dynamic module. Then we can do something as well. That's a method that we care about. Same thing for things like module builder. What would we care about on a module builder? Did you call define type? And I might move all this out into like a separate class to do this. I'm just kind of inlining it all for now to make it simpler. So we could say define type. On a type, we might care about that you're going to invoke something called define constructor. Okay. And then on constructor and method builder, what we would care about is, did you call getIL generator? All right. So this is kind of the first pass. We haven't generated any code. We don't have tests in place, but this is at least sort of a start, and what we could do is we might generate code that actually doesn't do any interception. We might just generate a C# file that has comments in it for now to say, let's write some tests to see, when I write this code, did I get these locations or something like that. I think at this point I'm going to stop with this stream for now. I laid out what the intent is, started writing a little bit of code, and the next part, which I will probably do tomorrow morning, I'm going to continue on with this because I'm on vacation. Who doesn't write code on their vacation? But I'm going to probably do a stream tomorrow morning, another random code stream, and we'll see how much farther we can get on this and make any progress on it. As I said, I'm traveling Tuesday to San Diego to speak at a conference, so I won't be doing any more streams the rest of the week, but I will be doing that random code stream tomorrow morning. I will probably be doing some more the abandoned planet streams. I'm hoping to get that done today, and then maybe I could do an afternoon Halo Reach stream starting that tomorrow, or I might wait until I get back. We'll see. But in any event, I'm going to stop here. I want to thank everybody who's been watching either live or in the future. If you haven't subscribed to the channel just yet, please do so. I greatly appreciate it, as I'm trying to get to 5,000 subscribers now. That's my next goal, so any new subscription helps, and thank you in advance for doing that. If you've already subscribed, I appreciate you, and I hope to see you in the next stream. Thank you all for watching. Take care, and I hope to see you in the future.